You've all just heard James's wonderful talk there. Lovely to also introduce Ian Cooper. Do you want to give everyone a quick self-intro?
Yeah, sure. Hi, my name's Ian Cooper. I'm talking about microservices here at NDC. So I focus a lot on distributed systems. I quite often teach a course on messaging systems at NDC and other conferences. And I currently work for Just Eat Takeaway, which is Menulog here. We, I think, send about 1.5 billion messages across our system in a given day. So that's me.
It's a lot of messages.
It's a lot of messages, yeah.
Excellent. So the way we're going to run this, we've got a couple of questions coming in from the chat. We'll take open questions from the audience. If everyone's completely silent, I've got a few backup questions. I will, if you from the audience, I'll just quickly repeat them so that the live stream audience can hear them. Hopefully they can hear me standing here. But yeah, throw it over to the crowd. Anybody want to get us started?
Yeah, so I guess like going back to the email service in the previous call, in that context, you kind of like you've got an order service which will receive like the email address and those sort of things. So you would have that information to then be able to call the email notification service to do that.
Yeah.
I guess what like in a bigger system where you have I don't know, some sort of subsystem that like does its thing, wants to send notifications about that, have like a custom ID or those sort of things. Like then, like I think, having that like a synchronous command and then like is what I want you to send, is what I want you to send it to. But then like that notification service needs to be able to like have the email address for that customer. Like, how do you kind of manage? Or like what are sort of strategies for like how that notification service can kind of have or get the kind of email addresses and stuff.
Okay, so I'm going to try and summarize that quickly. So the question was about the order service and email service interaction. If the order service is asking the email service to send an email with an asynchronous command, the order service presumably already has the email address because it's just collected it as part of taking the order. So we can provide it to the notification service. But in a bigger system, you might have other services that want to send emails. Where's the email address coming from in those situations? Does the notification service already have it, or does it have to get it from somewhere? All that kind of stuff.
So I don't know. The first thing I'll say actually is that obviously some of the examples in the talk are a little bit contrived, just to try and make the point. Just try and answer the question though. I don't know if maybe more of a theoretical answer first, but I don't know if part of the problem is like we've gone too far with microservices. Like if you come back to this idea of like data residency and who owns. Like one of the core principles is that a service owns its own data, right? If you've broken a system down into like 1 million microservices, you've got a service that's just sending emails, which I realize I just had in the talk, but like, is that the right breakdown for the system? Like, should that email service live with the account service where all the customer information is, for example? Like, should that be its own slightly bigger, if not quite as microservice? Like, should all that data just be together? So instead of having an email service that's sending me emails, you would just have like a customer service or an account service, which already has the customer information and the account information and the address information or whatever and the email address, and that's where that command goes. That would be this like maybe this
like this kind of the subsystem knows the details of like what needs to go into the message. So like funneling everything through the like customer service, then the customer service then needs to know too much.
Yeah, it gets a lot of responsibility. Yeah.
So yeah. James mentioned this idea about thin and fat events. I guess we talked about quite a bit. So generally, if I create an event, let's say I create an event for an order, right, for my pizza, and I can inline effectively all the information. So I could put in the customer's address, the restaurant's address, all the details of the order, right, exactly what pizza was ordered, everything else. Right, we get quite a big message. The problem with that is a thing we call a transitive dependency. So it's exactly the same thing you get in databases when you're thinking about how you arrange your database. The problem I've created is that if that's someone who now owns what customers look like, or what restaurants look like, or what the catalog entries look like, wants to change their format, that's going to affect this message. And that ripples out in a big enough system everywhere, all right? So there's this idea that says, well, the only things in the order should be things that the order owns the lifetime of. All right. So the order may have effectively things like you've ordered 4 of SKU 1219, and maybe it tells you tiny bit of additional information around that, right? And so you're figuring out what belongs to that order ID. When that order ID goes away, we don't care about the things it contains anymore. But things like customers, restaurants, they persist long beyond that individual order, may be used in many orders. So typically if you go straight for, okay, I'm going to remove all transient dependencies, right? Same sort of thing you do in database technology. You replace all those with an ID. So you say, right, I've got a customer ID, I've got a partner ID, I've got a SKU for the given piece of pizza that I'm ordering, right? So anyone downstream now says, okay, well, I've just got an ID. If I want that data, where do I get it from? Right. So the first rule is never do an HTTP GET. HTTP GETs are bad, right? Why HTTP GETs bad? Because if I go to get information from you, and then I go to get information from you again, and I go to get information from you again, obviously I'm making that walk a lot. And if it's the same piece of information, I should cache it, right? Trouble with my cache is it only has so much space potentially, but also first time I look for something, it's not there, and so I'm going to get a cache miss, right? So what we tend to use event carrier state transfer for is populating what we call a forward cache. So if I need the customer information, I get a forward cache of that information. I get a copy, which is created by you raising an event saying there's a new customer. That tends to mean I have the information ahead of you using it. And weirdly, other people get concerned about eventual consistency in messaging. Actually, you tend to be more consistent because anytime there's a change to customer, I will get a message and I will update my data store. If I'm relying on an old school HTTP cache, it may well be stale for a lot longer. Right. So that's one way we break down those big fat messages. We remove all the transient dependencies, and any service downstream that needs to do a lookup, it effectively builds a forward cache to do that lookup from. And the only problem you get with that is sometimes that's just not worth it. All right. It may be a tiny bit of data that you need, like I might need the weight of the total weight of the order or whatever, so I can figure out, is this going to go on a bike or does it need a car or whatever, right? So I might just choose to inline that. And it's the same choice we make in databases. Sometimes in databases, we choose to inline information because going to the other table and doing a join is expensive. So why am I going to do that every single time? So pretty much you're making the same set of choices. And that's what we kind of distribute those stuff by. What's what ECST tends to get used for is building these forward caches in many places. Now, you then get into the problem James is describing, is if I've broken things down and my service boundaries are too small, a lot of services now have all these lookups. So that strategy of real kind nano services looks a lot worse now because everybody's got a copy. But you can get around that a little bit. You can sometimes decide, I'm okay sharing that lookup table, provided you all agree. We're going to set the canonical format for it. And if we want a different one, we will actually fork on right. There are really good tools for doing this nowadays. One we tend to like most tools called Red Panda Connect, if you call Bentos. It will also do your HTTP scenario where effectively you get an event, you need to call a third-party service for HTTP. It's just a little Go executable, and you just give it a small file with what they call blob language inside it, which just lets you do some manipulation. But you can build those really fast nowadays. So Red Panda bought it. It's really an open source project, but it's really, really good for doing that.
Like we have email servers, like the business of email, yeah, they have to have this forward cache. Like,
oh, okay, yeah, I can answer that question if you. So yeah, if you want to communicate to the customers, all right. So how do you get? If I had a new service, how do I backfill data if it's all coming out of this ECST? They generally use a stream, not a queue. All right. So queues, when I consume a message, it gets deleted. A stream, I can pick something like infinite retention, right, on say Kafka, and I typically pick compaction. So what do we mean by that? If I have a restaurant, if I have 100,000 restaurants that I deal with, I want to give you a stream. The max I want that to be is really 100,000 long, right? If I give you every change for a restaurant in the stream, you've got to read, I don't know, 15 different changes to that restaurant, and I've got a few million rows for you to read through every time. So what compaction says is only keep the latest copy, and infinite attention says keep it forever. And that just means as soon as you add a new service, they start just reading through that stream, populate their local, their forward cache with the data, and then they can do lookups. So
How would you, if I can, I'm gonna follow up then.
Go.
How would you think about that from like a, because then you get in a situation where you're using the streaming technology as a database, right? You're using Kafka as a database.
Oh yeah, what Kafka calls it, Kafka calls it inverting the database or something. Yeah.
Okay.
Yes, you are. It's an interesting one, right? Because one question would be, why don't I go to the original database? And the answer is because the database is internal operational data, and I want to be able to change the schema of that for performance reasons or whatever, without really being forced to essentially worry about what all of you do. So one of the problems with Dynamo and doing a change data capture of Dynamo is if I change my internal structure, that ripples out and everyone else downstream gets hit by it. But if I raise an event, that's a contract that I'm going to basically keep. So I can say, okay, provided I keep maintaining that contract, if I make internal changes to representation, it doesn't really matter as long as that external contract, which gets back to the Apostles' Law, gets maintained.
Yeah.
So that's why I want to put it on an event, because on Kafka, because that means I decouple change to my internal state from change to the external state. One of the things that I've learned in software architecture over all these years is that decoupling rates of change is one of the most useful things you can do. In other words, you effectively find some mechanism that says that Chris and James, their projects can move at different rates, even though they have some shared concern that they care about. And doing something like the classic, anti-corruption layer to produce a public domain event is a really good way of doing that. I mean, I'm no expert on it, as this is a DDD group. There's some really interesting talks by Eric talking about the fact that people, when they think about microservices, quite often think about a microservice as being, my bounded context of my microservices. But actually, you can think about there being bounded context between the microservices, which effectively represent message state flowing between things, because it has a different language to the language inside the database. I think he calls them something like integration bounded context.
Yeah, is that also the term published language?
Yeah. So that's quite interesting. It's a tiny bit ill-defined, but you should see if you can find somebody who's smart enough to come and talk about it. And that's not me. But yeah, so that's an interesting idea. This, because it has the other language, you decouple basically changes in your bounded context.
Just a question on that. Like, obviously, someone has to own the schema, right? So you publisher could have a shared schema, but isn't that still the upstream bounded context that owns that schema?
So just going to repeat the question. So the question was about who owns the schema. Isn't it usually still the upstream context that owns the schema?
So Eric does talk about that, and it gets complicated. My kind of rule a little bit is I go back to, I don't know, we'll find out what James does in a minute, but I go back to once upon a time there's a set of specs called WS_messaging, right? Wow, journey to the past. And but they had quite a good, I still teach part of that because they've got this idea of not producer and consumer, but I've got to remember the terminology now. But effectively, what it means is that is the person effectively who owns the operation and the person who effectively consumes it. So the problem is that typically in messaging, what happens is people think, oh, the publisher is effectively the person that owns the API, right? But if what I'm actually doing is invoking an operation, in other words, I'm sending you a command, then probably you own the API, the person exposing the operations.
I said it's in the
Yeah. So typically you think about who's going to own that operation, and that is basically the API owner at that point, and they're the ones that ought to define the schema.
I guess my point was there's nothing in the middle. It's the part of the
Oh yeah, I guess it's conceptually there's a because it's not what's inside your context. It's what's your perimeter, and therefore your language may not be the language you would use internally in the project, because it may be a language that you've agreed with other teams to be how you communicate about things.
Awesome. There is actually a question. on the chat here. Well, I think it might be from someone. This question for Ian, given your history, is very testing.
All right.
Oh.
Hello.
We're back on the live stream. Sorry, everyone, we dropped out.
Right. So yeah, typically, you tend to find that you can get useful tools to both send and receive messages without having to write a kind of fake system. So the really good ones for Kafka, like KCAT, which will essentially say I can send messages, or I can just see a listing of the ones you sent, and then you can effectively use things, simple tools like JQ, to pass through basically what you've been sent or received and figure out, okay, does that actually conform to what I'm expecting? You can I don't really believe in fake message brokers. I think because the protocol, it's not like HTTP where effectively there's HTTP. So I can create basically a test server that talk to. Trouble with fake message brokers is this: what protocols are you using? And you might be using more than one messaging protocol internally anyway. So I tend to rely on, I'll just call the service and I'll just listen to the message it produces. The really interesting bit in this space that we're experimenting with, where I'm currently, is this kind of observability-driven engineering idea that says, in addition to testing that kind of contract the perimeter, you can actually listen to the telemetry. So there are tools like trace test that help with this. So you can actually figure out, oh, what did I make other changes as well by looking at the telemetry at the same time. But yeah, I would generally say just test the contracts. That's what you care about. Provided all the contracts match up, you should be good. Run one or two smoke tests when you deploy to production to check that some sort of synthetic transaction goes all the way through, to make sure that you haven't got a problem where, although in paper your contracts will match up, they don't in reality. But that's typically what I would do.
Have either of you used consumer-driven contract testing with event-driven architecture?
Yeah, briefly once upon a time. I used Pact.
Yeah.
Once upon a time before I was at AWS.
Any thoughts?
I mean, I think I'd echo what Ian said mostly, is that I think testing that the schema, the structure of the events is one of the tightest points of coupling you will always have. Like a lot of the problems I've encountered in event-driven systems is where the schema changes for some reason that you didn't expect, and suddenly a field isn't there anymore that was there. So I think making sure, both as a producer, that you're sticking to a schema, but also as a consumer, you're testing the fact that something might change and how your system handles that. I think that's useful in both directions. How you define that, whether you use a more defined contract testing tool, whether you're just, I don't know, taking the thing that you receive in your test system and deserializing that into JSON, serializing that into JSON and comparing that to a JSON schema, like however you're doing it, I think that the tool, I think testing the contract is the important bit. The other thing I would add, I think, is important as well, though, is to test the actual flow of a message. So like, I don't know, whatever messaging technology, if you're using RabbitMQ and you've got queues, you're going to, somewhere in your code, in the configuration of your application, that you're expecting a queue with a specific name or a specific piece of configuration. So making sure that the event makes it to the place you expect it to. If you're a producer, it makes it to the queue you expect it to, it makes it to the topic you expect it to, but also the other way around, that your system correctly subscribes that. It's where I really like. So a lot of the stuff I do aside from event-driven architecture is a lot of serverless stuff. When I was at AWS, I used to do a lot of serverless things. It's one of the things I really like about more serverless technologies, that I can just spin up I can spin up a bus, I can spin up a queue, I can spin up a topic, completely ephemeral environment, run some tests against it and turn it all down again. And you can test more easily that whole end-to-end flow. Now, of course, if you're using something like Kafka, you could do that with, I don't know, Docker Compose. You can spin everything up, inject your message, have something listening at the other side, like Ian said, and check that the thing comes out the other side. So yeah, I think it's important to test the floor and the contract is the thing I would add.
Right, back to the crowd. Next question. I think, yeah, Lee.
I was just wondering, do you have like a rule of thumb for like how many different event types you might want floating around in the context? Is there ever a point where you go, this is far too many events now, are we missing an abstraction or something? Is there anything you look at?
So the question was, do you ever find, is there a rule of thumb for is there a limit on how many events you should have in a context or a context producing event types that would signify that the context is too big?
Yeah. I think that's where the importance of doing the design work up front for me is important. Like doing event storming is a good example. If you do an event storm, you might end up with 4 things that you might have order created, order placed, order, and you're like, these things are kind of semantically similar. Let's agree what the right language is to use there. So I guess if you've done the work up front to do the design work and understand the events, if there are actually just that many events in the system that might happen, then that's just the nature of the business problem that you're solving, the thing that you're building, right? I guess is the question more if you've got is it the number of events totally in the system or the number of events inside an individual service? What's just I suppose check that distinction actually.
Well, I guess that might be like you've come to the point where you're going, oh, we've got 20 events now.
Yeah.
Are they all relevant at this level of abstraction? Could we move them down to, like you say, another server?
Okay.
That maybe cares more about a subset.
Yeah, I'd say that's very context specific. That's a
You fancy a hot take?
You got to have a hot take. Go. Yeah, all right. Always love a hot take.
All right. Don't expose your domain events outside your domain. Typically, if you're internally inside your microservice practicing some kind of event sourcing, I don't care about any of your events. Thanks very much. That's lovely. I'm really pleased for you. Fantastic. You've got some event sourcing going on. What I wanted the outside as a summary event. So the problem, 2 problems. Some are practical and some are conceptual. The practical problem is that you essentially, if you have a topic and you are producing a whole load of what I think was as kind of like event sourcing style delta events, right? So for a restaurant, you had restaurant phone number changed, restaurant on shift manager changed, or whatever, etc., and a whole series of them. Some of the problems with those can be they've got to be in sequence. And sequence is generally much harder in distributed systems than it is locally. And the far side then has to do some gymnastics because it has to try and understand what is the actual event type that I need you want me to deserialize, as opposed to saying there's just always one type on the same topic, we call data type channel. Generally, it's easier just to send one type of event on one given channel. If you've got sequence, you can't send them on multiple channels because it's never going to work. So it's much easier if you send one type of event on a given channel, right? Second thing is, if you give me all of those kind of domain events, the ones you might be using for event sourcing externally, I am now exposed to the details of your domain. You have coupled me to the internals of your service. Because as soon as you change anything, I now have to know about it. I also have to understand how to interpret those things to build a picture. I'd rather you just told me this is what the restaurant looks like, because downstream, that's what I care about, right? If the reason that it changes is important, that's just a part of the summary that you send me. And typically that also lets you get infinite attention and compaction, all right? I think event sourcing is very valuable in some circumstances, but I think it's valuable inside your domain, not across other domains. It's too much bleeding of your bounded context everywhere else. Keep it to yourself.
Yeah, I think the other thing that I've run into with that is you end up writing the exact same remodel code in like 100 places. Mm-hmm. Like, why have I built this exact same report in
Yeah, exactly.
Yeah. Michael?
I'm just going to say, traditionally, a lot of organizations who are new to event-driven architectures sort of go, I'm still Kafka now, event-driven.
Yeah.
What do you feel is the minimum maturity where you can actually go, yes, you're ready? What do you see as the essentials?
So the question for the live stream, organizations that install Kafka and go, we're event driven, not enough. What's the minimum maturity to say, yes, what's the Ian Cooper and James Eastham seal of event driven approval?
I guess what I'd come back to is why you're doing event-driven architecture in the first place. I quite like what you just said, actually, the rate of that optimizing for the rate of independent change. That if two teams, 3 teams, 10 teams can all work more independently, they're not relying on another service always being online in the kind of typical synchronous style. I think when you've got teams that can actually move properly independently, communicating properly asynchronously, regardless of what middleware, what technology you're using, that's what I'd start to get towards. Okay, you're actually doing this for the right reasons. Now, is that coming back to why we're doing this in the first place? It's not about using Kafka or using Kubernetes or serverless or whatever. It's about what are we optimizing for, which is, I like that phrase of optimizing for rate of change. So I think that's what I'd probably look for. It's not put as well as Ian spoke it.
So there's a thing that we make hard, but I don't think it's hard to think, which is understanding the way in which your business can be asynchronous, right? So I always think it's both hard and not as hard. So I know you can't believe it by looking at me, but I'm actually old enough to, when I was a student, to have worked in offices that were like at the beginning of automation, right? So they still had lots of pre-automation. And I guess there are probably lots of businesses that are just not automated still. And the way typically somebody worked, right, is you had your desk and you had an inbox and you had an outbox. And my job was in the post room. So I've always worked in messaging. Right? I used to deliver stuff to your inbox, basically, and collect it from your outbox. Best thing was I was a trained operator of the thing called the Sovex, which is like this dumb waiter that went to all the floors. And it would drop the things off, and occasionally it would break, and you have to go and and fix it.
A message bus.
Yeah. had a lift there at the top where the boss wasn't allowed in because he wasn't a trained Sovex operator, so we'd nip up there for a break and a crafty cigarette. But those business in that form was always completely asynchronous, right? Because essentially you've got a stack of work, which is your queue of work coming in, take an item off, you then work synchronously, you flip through the file, do stuff. If it's urgent, you might pick up a phone, so you might make a synchronous communication at some point to somebody, then you do the work and put it in your outbox. When you had to process stuff in a very asynchronous fashion, right, where literally it moved between each individual process and another. And you can still model most things that way today, but what you have to better do is break your business down into, okay, where are my processes that are run a kind of like transactional or synchronous piece of work where effectively I can't break it up? And where are the bits in between where effectively it's my inbox and outbox and someone pushing the mail car out? When you can figure that out, it really helps. I think that I was chatting to someone earlier saying, I think even today, though, we struggle a little bit with where am I doing some orchestration? Where am I doing some choreography? And orchestration and choreography is not what I think. There's a bit of a meme out there that orchestration is I'm doing commands and choreography is I'm doing events, and that's not really true. Orchestration means that there's someone managing a state of a given operation through a series of steps. And choreography is I yeet stuff into the wild blue yonder and hope that it comes back, right? And there's a problem. I don't think it's fair to call it lambda pinball, but I tend to call it pinball, which is I haven't got enough of that orchestration and I've got far too much choreography. And what happens is it's like I fire an event and it's like a pinball machine. Things just light up randomly and go places and no one's got any idea how it works and not predictable at all. So we need to trade off that balance of a bit more orchestration, a bit less of it, that stuff. So I think understanding your business process and your flow is critical to really being able to do event-driven architecture separately. So I think you were mentioning earlier, right? It's understanding the flow is really quite critical, a part of basically being successful at it.
Giving a certain level of observability and monitoring.
That's one, yeah. Someone in the room was just saying, you also need to be good enough to be able to do some observability and monitoring to figure out what's going on. Yeah.
Question over there?
James, you made the distinction with events that it's something that happened in the past.
Mhm.
What would you suggest for the opposite problem where you need something to happen at a specific time in the future? Like, for example, with the pizza ordering system, someone schedules, they want that pizza delivered at 7 p.m. tomorrow night.
Yeah.
Like, should the order processing system just, if you want to do it, should we choose an event pass that to actually schedule the message, or should the kitchen system, like, or should you fire off the event immediately and say, don't process this time so this has to hang on to it?
The question, repeat the question for
Yeah.
the audience. So the question was, if there's if events are things that are facts that have happened in the past, how do we model or think about things that need to happen at some defined point in the future, not immediately?
Yeah.
Like, for example, someone wants their pizza, they're putting the order in at 1 p.m., they want the pizza at 7 p.m. Who owns the wait state of that?
Okay, so I basically work for what you guys call Menulog. So here's what we do. Okay, so if there's a distinction between messaging or stroke, sometimes commands. The old one is basically I want something to happen in the future, or I want you to give me information now to query it and eventing things in the past. So what do we do in this particular instance? So we give the if it's a future order, it goes effectively to the thing that does order orchestration. And that thing essentially will hold on to it until it reaches a window where effectively we say that's now committed and the restaurant needs to understand that. So typically, when you log into what we call OrderPad, you'll see them basically, if you go around any places, I mean, whatever provider it is, you'll see they've got a little handheld terminal thing that they basically use. And we will tell you the orders that I think are numbered out at the minute 24 hours in advance. So 24 hours in advance, you can see any orders in the next 24 hours and you can see what time they're due. For some catering scenarios, that can be much longer. If it's like big orders that basically you have to get the food in and order, etc., we may indicate to you quite early on, you can see that order's building up. But you may find a cutoff as a restaurant like 48 or 72 hours for that order. At which point we then push that through to you. So we keep it in suspense till this point where it becomes, if you like, irrevocable. And then that's the point where effectively we forward it to your device. So yeah, typically you store those kind of orders. We just had a massive internal argument versus AWS scheduler or courts to do that work, but that's a separate whole kind of conversation.
I mean, I could give my opinions on how you could do it, but I think Ian's actually doing it. So,
were you on the EventBridge team or
no? I did some quite a bit of work with some of the PMs and some stuff at reInvent, but I wasn't actually on the team. No.
Was there a question about?
I had a follow-up from the earlier question about domain events being private, which I totally agree with. But I'm currently exploring the idea that the data mesh may be the boundary of what I consider my domain is a little bit bigger than what I previously thought. Rather than just my service, maybe it might be a table in a data warehouse that I collaborate with some data people to create a data product. How do you guys think about that idea, about the boundary of, where's the boundary of private and public?
The question about where is the boundary of private and public, and this has been raised recently in the context of data mesh, where the boundary of the domain or bounded context might also include some part of a data table in a data warehouse somewhere.
Yeah.
So, yeah.
I mean, I think any question around what do we make private, what do we make public, I'd come back to Postow's law most time. Like anything that you do expose externally should be incredibly well considered. If you're going to put a piece of data into a data table and commit that data, and we're going to put that data there, and that data is going to be in this format. And once other people start using that, then you kind of there's a quote, isn't there, about APIs? If you put something in an API, someone's going to use it. I can't remember exactly what the phrase is, but
anything that can be depended upon will get depended
that's the one. Anything that can be dependent on will be dependent on. Yes, exactly. So I think where you draw the boundary, I think I'd always make sure there's a really good, well-documented reason about why exactly we're exposing a piece of data. Like, why does a certain other team need to depend on that specific piece of data? What's the reason for us exposing it? Are we putting it in this data warehouse just because we've got it and we want to expose it because, hey, look at all this data we've got, or are we actually doing it for a very good reason? Again, I'd come back to the why of why exactly we're exposing this data and for what reason does the team need it, and that's where I always start with all these conversations. I think exposing what's public and private, I don't know if there's like a hard and fast rule that would always apply to every single situation, because as long as you're putting a piece of data in there that has a good reason to be in there, I think that would be. The other thing I will say, I suppose, is having some kind of anti-corruption-esque layer where you're not directly exposed. Let's say you've got an internal model of an order. You're not going to put that exact representation of an order exactly as it is into your data warehouse, into your data mesh. And I'm not overly familiar with data mesh. I understand the kind of idea of it, but having some kind of layer to translate between, okay, we've got this internal representation of an order, and we've got our data warehouse, and we want something in the middle to kind of translate that makes sure we're only exposing the data we want to, and B, if we need to change this, that's fine, because we've got this little translation layer that's translating the data between the two.
We don't know. We actually that's a live conversation that I'm having with other people. I'm pretty clear that I think when we talk about operational versus analytical data, you can't touch my operational data, all right? Because I need to be able. That's operational data for people that don't get the distinction. Operational data in that context would be the things that are internal to the microservice it uses to perform its actual functions, and the analytical data is the stuff we share outside. So there's a really good paper by Pat Helen called Data on the Inside versus Data on the Outside. And so typically you would think of analytical data as being outside data. That's data that's published out my service. So the simple model would be, oh, well, you're analytical. What the mesh gets, it publishes basically analytical data out of the service. And operational data, you don't get any of that. But you're definitely right. So what's happening a little bit is the lines are getting very blurry, because when we start to talk about things like the ubiquity of so S3, for example, is so reliable that people want to use it for all sorts of new reasons, like say, well, couldn't my data just all live in Parquet files in S3, and then I'll just expose it by DuckDB or whatever effectively? And it couldn't actually be your data operation, etc. So there are definitely developments here, I think, in terms of how we think about things that cause people to question whether those lines are much more blurry than we think. But I don't know. But I don't know. I feel uncomfortable around some of this. The questions are being asked, but I don't really have any experience of what would happen if we relax those rules and let you turn some of the operational data into analytical data, because you could generally have that table or whatever. I don't know. Is anyone else dealing with this problem and got any thoughts? It's definitely a little bit of an intriguing one.
Yeah. I can say some of what I'm saying or thinking about it. So I think to your question around, is there a table in the data warehouse? I think there's a distinction that a lot of people miss between logical ownership and physical ownership. So the fact that the table is in the data warehouse is a physical location of the table. But if the team that owns that context is responsible for that table, that's their logical ownership. They might own multiple tables. Some of those tables they might treat as private data for their own internal analytics computation, but then they have to make at some point some of that data public, and they should treat that as a contract, because once it's public, it's a contract. So just because it's in the data warehouse doesn't tell you anything about if it's public or private. It just tells you that it's in the data warehouse. The logical layer that you impose around that, which comes back far more to the team ownership and what the team exposes to other teams, will tell you about whether it's public or private, what rate of change it has. Once it becomes public, that's what the data mesh people call a data product. And then you think about it like an API product. It's a contract, you version it, you control it, you document it, you let other data products consume it. But you might need to do some analytics to produce that data contract or that data product, and you might want to do it in the data warehouse because that's the easiest place to do it. So as a team, you can make that choice. But I think a lot of the tooling is not making it easy for you to distinguish between what's private and what's public in that kind of context. And actually, Pat Helen has a great paper, not just the data on the inside one, but also the concept of an emissary. The idea that the context can have like an emissary that it sends off to run in like another kingdom. So it's like this little like diplomat we own it, but it's over there. I think that's kind of a good metaphor for a way to think about the data mesh evolving in that space, but it's very much an evolving topic.
I just pitched a talk to Kandinsky about the emissary pattern. There you go.
Hope to see it there.
It's another place where they're G.
Yeah, the G word, governance.
Governance.
Oh God, yeah.
Made me say it again.
We've got soap in the bar.
Oh, good.
There's another question.
I was just wondering, what's the worst thing you've seen done under the event banner? Like any horror stories or famous mistakes that
I was really broke a system. So it's a really silly story. Do you know how things go when you learn about a new technology and suddenly everything has to use that new technology? Like I was working for a startup, cybersecurity startup, and the whole premise of the startup was that we'd send out fake phishing emails. So a company could come and sign up as an IT person. You could sign up, and then people in the company just start receiving phishing emails. And there was only me building it, the startup, on my own. And I decided to build microservices in event-driven architecture, obviously, because that was a good decision when you just learned about microservices in event-driven architecture. And I made the whole scheduling and email sending thing completely asynchronous. So the scheduler service would say, look in a database, there's an email ready to be published. There's an email ready to be sent, publisher, email ready to send, event. This was before I had the kind of knowledge that I do now. Email ready to send, event goes, email service consumes it, publishes an event back, which then includes a correlation ID, which marks the record as sent in the scheduler service, so that the next time the scheduler runs, it doesn't think there's an email to send. And then before I knew the importance of schema design, I made a change to the structure of the event, which meant the event came back and the record never got marked as sent in the database. And I can't remember how many emails we sent in the end, but we sent a lot of it. I think it was in the tens of thousands of emails that went out. So you imagine some poor person sat there reading all these emails from Domino's that don't really look like a Domino's email, but they might be. So yeah, it was I just think of using a tool in the wrong place for the wrong reasons and not really fully understanding it. So yeah, that was fun.
I love this as a great example of we make mistakes, we learn, we survive.
Yeah.
You're still around?
I'm still here. Yeah. Now I know not to do that.
I think probably most of the significant pain points I've seen involve really big messages. When somebody has sort of basically said, maybe if we just ship the whole database in the message, that'll solve any downstream problems, sort of thing. Already, that seems to be the problem. Which is kind of more common than you think, but I think people get to it by degrees, right? Because they're like, oh, I should send this in a message, and it gets what they're sending gets bigger and bigger and bigger and bigger and bigger, and they don't know when to stop. I mean, so generally the solution, I mean, we did for say, the current place that at some point menus got big, right? At some point you start out as a business and menus have got 10 items on it, and then you start to get customers have got more stuff. Then you start to get groceries on, so you really got catalogs rather than menus, and suddenly your old thinking just doesn't hold water anymore, right? So nowadays we stick the actual item in an S3 bucket. It's a bit like the claim check pattern, but it's not explicitly claim check. And you say, well, actually, where catalogs live is in S3. What lives on the message is a notification that there's a new version been published of that, which you can choose to do whatever you wish with as a downstream consumer. We don't give you all the contents because that'd just be insane, right? So and then also I've seen examples of that where effectively it's actually like a job of stuff to do. And the problem is that the processing, your worker sits there chewing at this thing for 5 minutes. And there's no way for ops to know, is this thing still working? Because the queue is not actually, doesn't seem to ever move. Or is it just really sitting there swallowing a big fat message? And that was one of my mistakes. And we realized, oh crap, what we should do is break this thing up into a smaller number of pieces so we can actually see some motion on the queues and then kind of join it all together again at the far end. But yeah, I mean, the other thing that is just a tip, because it reminded me of that, is that one thing people get wrong is when they move to Kubernetes or something, and they basically have some default scaling policy which says, oh, it's based on CPU, right? And your poor little worker that's doing its best to try and consume the queue and is running quite hot, they keep going, oh, we better start scaling, but we need more, especially with his Kafka, it's kind of like more workers aren't going to help you. You've got more than partitions now. The key issue is queue length. That's what you need to monitor, is the length of the queue building up. So that's what tells you how effectively things are going. CPU is roughly irrelevant at that point. So yeah, it's not that kind of failure to understand operationally what is the problem, right? Which is key. That's the other thing I see quite a lot of, which is a terrible one, which is people don't know anything about queuing. So I don't have to know queuing theory. There's characters that just do it for you, right, on the web. But queuing theory is this idea of rate of arrival, rate of consumption. Rate of consumption has to exceed rate of arrival, basically. So it's a kind of, my classic example is if you're working in a bar and there are more customers ordering drinks than there are bar staff, queues develop at the bar. So you have to have more bar staff, right? But what happens, people don't know about that is they can't therefore predict it. You get policies like, oh, we just always have 100 partitions for every Kafka topic. And you're like, why? And it's like, well, because then we never run out of partitions. And you're like, there's maths that would tell you how many you need, you know. But yeah, that's quite a common one that comes up.
On the topic of those big fat messages that take a long time to consume in a queuing environment where you have a visibility timeout, like SQS, that's another great flow-on effect where the visibility timeout might be 30 seconds and you take 40 seconds to process the message. And because you haven't processed it, the queue releases another copy of the message.
Yeah.
Cascading.
Yeah.
Ballooning failure. That's lovely.
One let's talk about what didn't happen to us, but I'll tell the story because it happened to our competitor Deliveroo. So James mentioned basically expiry, right? Expiry is really important because so Deliveroo had an outage and they had an lovely little event-driven architecture and they had an outage for like 4 hours or so. When they finally fixed the outage, they kind of kicked it back to life and everything's fighting through the queues. But the customer experience on it was like this, basically. So it's about 7 o'clock in the evening, and I'm basically all trying to order McDonald's, and doesn't show up. Nothing happens. I'm on the phone complaining. You've ruined dinner. I had to figure out something else. The kids are crying, or whatever. And then everyone goes to bed, and then about midnight, 1 o'clock in the morning, they were all getting delivery drivers knocking on the door, going, "I've got you McDonald's." So basically, they were adding insult to injury at that point. So always have a message expiry, basically.
There's another question on the chat. Any advice on item potency on the consumer of events?
Good question. So I think that's one of the important reasons why having some kind of ability to include some kind of identifier in the event that you publish. So obviously I had the cloud event specification on screen. There's other ways to do this, but having some kind of identifier that the producer includes when they publish the event means that as a downstream consumer, you can look at that and immediately say, have I seen this specific event before? If you have, great, you can just drop it. That's not necessarily a failure as such. You would still return an okay, yes, we've processed that message, but you've just dropped it. Equally, if you haven't seen that, you'd store that identifier in a cache or some kind of location. There's a couple of places I've seen that go wrong though. The first being if you need to retry an event for some reason. So if you receive an event, you process it successfully, you store that idempotency key, the event identifier, in some kind of storage location, and that's where you check to see, have I seen this event before? Really, you need a way to expire that, because if you need to process that same event for some reason, again, there's some kind of failure and you need to retry it, well, you've got the exact same version of that same event and the records in the cache or the storage, so you're just going to say, yeah, we've processed this in happy days, and you actually want the ability to process that again. So some kind of caching ability, some expiry ability, should I say, for that idempotency layer, and that will obviously depend on what exactly it is that you're doing. The other thing that's tripped me up before, at least, is only relying on that unique event identifier as thing for idempotency, because I've had a situation in the past where the producer actually published 2 versions of the same event. Imagine it's that order confirmed event again. They had an issue at their side, so they published 2 order confirmed events for the same order, but with a different event identifier, because there was a problem at their end, not at my end. So I was only relying on this unique identifier for idempotency, which then meant, oh, well, this is 2 different events and process them both. So there is a bit of a balance between having this unique identifier, which is good, but also potentially using some kind of actual business identifier, if you will, to actually identify it. And then, of course, that idea of expiry.
Not much to add.
Excellent. Yeah.
I think James, you mentioned, or you've shown on the slide as well. There's an Ethernet queue to the service on top of that broker. Just wondering, because I thought message broker had back pressure. baked in.
So the question is about the idea of a service having like an input queue and in like a storage queue as an input. How does that relate when the broker has back pressure management?
Yeah, I guess what's useful, I thought.
So I think, yeah, I see your point. I think the nuance I probably missed in the slides is that there's different types of channels, different types of Ian's mentioned streams and queues. Streams are typically more durable. Queues are obviously, you've got one consumer, they process that, then the message gets deleted. And then you've got buses or topics where the message is completely ephemeral. So because I know the AWS service as well, you've got Amazon EventBridge as a service where you publish an event to EventBridge. EventBridge will distribute that to a destination, but EventBridge isn't going to durably store that event, right? In that situation, that's where I think it's valuable to have some kind of durability inside your service as a service, because the actual throughput of the message is ephemeral. If you were using some kind of like Kafka as an example, which has an element of durability. Now, I wouldn't say you should use Kafka as a database, but this is why we can have different opinions and talk about these things. But in that scenario, yeah, you probably wouldn't need quite as much, because then you'd be putting a queue in front of a Kafka topic, which already has an element of durability anyway. So that's probably a nuance I missed in the actual talk. So I appreciate you mentioning that. Thank you. I hope that makes sense. Yeah, no, yeah, that's fair. That's a fair comment. Yeah.
My question for the sort of developer experience stuff, how would you document your events and document how events flow through the system?
The question is for developer experience, how do you document your events and how they flow through the system?
So documenting events, so there's the async API specification, which is similar to Open API. It's just a specification for defining events. And then there's a really cool open source project from an ex-AWS guy called Event Catalog. So a guy called David Boyne. And you can load in your async API. So each individual team would have their own async API definition. And then you combine them all together into this single front-end application. And that will then let you visualize how all these things are talking to each other. You can visualize the versions. You can go and look at, I've got my orders domain, and my orders domain has these events. And even though, let's say your orders team has got one async API specification and your kitchen team has another async API specification, as long as you've got the naming the same, the event catalog product will bring all that together. So you can actually go and look at, here's my order service, here are my upstream services, here are my downstream services, here are the events. I can go in and generate code bindings for them events. So that's a really cool open source way of doing that. I don't know if Backstage has support for stuff like that now, but I think the async API spec is the important one.
Backstage supports async API now.
They forked it.
They support it.
Oh, so they forked it, right?
Yeah.
I said what?
They support. Yeah, you can load async API documents to Backstage.
Yeah, and there are at least I know in .NET there's I think there's a library that Lego built that allows you to generate async API specs from your actual application code.
I think they've just given it to the async API project on the
Oh, right,
Linux
nice.
Foundation.
Okay.
Yeah,
Cool.
so Lego just handed it over to Linux Foundation.
Okay, cool. So yeah, there is tooling that can make that slightly less arduous, but yeah, I think having an async API spec that describes your architecture and then some way to visualize that, whether that's Backstage, whether that's Event Catalog, which is a pretty cool open source project for doing that kind of stuff. I don't know how you do it, just the
Yeah, we use async API. What we do with async API, once you've given it to, you put it in a repo, then we pull that information and then use Polemy to create the infrastructure you need straight off the definition.
Oh, so you actually create like the queues and the topics and stuff from the
async API.
Oh, nice, that's cool.
Related, how do you, I guess, following the evolving sort of X-registry conversations, the
clemences?
Yeah.
Yeah, I only a little bit. I know he's, because there is we tend to use Confluent Schema Registry, but he's effectively, I think, trying to develop an independent sort of.
More agnostic.
Yeah, I mean, I guess because he works in Azure and Azure Event Hubs and stuff, I guess he's trying to figure out a way of not being forced to take the Confluent Schema Registry API. But yeah, it looks very interesting. I think schema registries are. So there's this, they are very useful in order to make sure that you are playing by the rules. But the interesting thing, I think, comes particularly they're kind of this exchange point between the kind of operational folks doing messaging and producing messages and the data folks who then tend to consume it all and do stuff with it. They want you to, they need you to kind of keep to that schema. And so they're useful to have those because it just provides that G word stuff for all your events and messaging.
Yeah, I mean, I've been trying out some. So obviously, I work at Datadog now, and I've been trying out some interesting stuff where, like, obviously you can have the best documentation in the world, but the truest representation of what the structure of your event is the event that actually hits the bus, right? So I've been trying to build some things where you almost like hook an additional consumer into your system that basically I want to see every single event. I don't care what it is. I just want to see it. And all they're doing is collecting that event, pulling out the schema of the event, because obviously you don't want to put the actual payload of the event anywhere that's not inside the system because you don't want to start exposing data, and just logging the schema of that event somewhere. So again, I was doing that inside Datadog by just creating an event, Datadog, this concept of events inside Datadog, which isn't necessarily an event in the way we're talking about it, but just storing, here's what an order confirmed event looks like. And then you just can go on with a query inside your observability backend and say, show me all of the order created events. And then you've got all your schemas there in your observability backend. That doesn't necessarily need to be Datadog at all. That could be anything. It could just be dumping them into an S3 bucket, right? Because I don't know, I'm bad at documentation. I'm a developer and I'm bad at it. So like, I think the more you can do to try and at least help to document your system from the actual things that are actually happening inside the system, I think is quite useful. But that's, again, I've sometimes been batting around recently trying to make work in a sensible way.
Yeah, AWS did that.
Yeah, Event Bridge schema registry. Yeah.
Just on that last comment,
yeah.
Do you feel that's like writing your tests, you code up your written code?
The question is documenting your events based on what's on the bus, like writing your tests after.
It's a good point. It's an excellent point. I don't know. I think with the best will in the world, I think things will slip through the cracks, like things will break. So yeah, I'm would be more of a fan of having the stuff, at least to be able to see what I might have contract tests, I might have the tests, I make a change that for some reason means the contract tests still pass, which means the event makes it, and then something breaks somewhere. I'd like to know exactly what that thing, the structure of the thing that was published.
Yeah.
Might be nice for anomaly detection too.
But to be able to diff,
field started getting dropped.
Then
that's right.
Really good for automating G-word.
Yeah. I think the reality in lots of situations, right, is that most things have, even if you decide tomorrow that you're going to do the right thing, you've probably got a ton of legacy. And the problem is that essentially going back through all that legacy and getting it to conform then becomes this obstacle. People go, well, yeah, no one's going to go back and document what we've got. So even if you documented a little bit you had, that becomes ineffective. So the ability to have tooling generate at least first versions of the documents for the existing stuff can really help you establish governance for all the new stuff too, because you can say, well, actually we do have everything documented.
Excellent. So there might be some more questions, but we are past 8 o'clock now, which is actually probably past when we're supposed to even be in this room. So I think we might wrap it up there, but please join me in thanking once again our guests, James and Ian. It's been wonderful.